Okay, hello everyone. What we're going to do is we're going to take a look at section 18J, which is Independent Events Part 2. Now the reason why we're going to go ahead and call this Part 2 is because we need to now go ahead and mathematically define what it means for two events to be independent. Because remember before what we said is that independent events are physically separate events, and if we can physically separate the events, then generally speaking we can go ahead and talk about those events as actually being independent of each other. But that's not going to be good enough. We need to be able to actually mathematically describe that. And in order to mathematically describe that, we first need to go ahead and take a look at conditional probability. And now that we know what conditional probability means, we can now go ahead and define independence. Take a look at what we have. If we can say that the probability of A given B is the same thing as the probability of A, then that means that regardless of what the event B is, that probability or that outcome will not affect the probability of A at all. And therefore we can say that those two events are mathematically going to be independent. Now it's the same thing over here. If we go ahead and take the probability of B given A, if that is in fact equal to the probability of B, then we know for a fact that even though you have the condition of the event A, that outcome or that event does not affect the probability of B occurring at all. And so that's why you just come up with the probability of B. So even in this case over here, we're showing that the that the events A and B are mathematically independent events. So let's go ahead and just look at the mathematics then. We already know that the probability of A given B, by the definition of conditional probability, is going to be the probability of A intersect B divided by the probability of B. Now what that means then is that if I go ahead and multiply both sides by the probability of B, I come up with this nice statement here which says that the probability of A intersect B should be equal to the probability of A times the probability of B, assuming that A and B are independent events. And notice if you use the conditional probability definition again here, you'll come up with the exact same result. So what that means then, now that we know how to define conditional probability, if we know the condition makes no difference whatsoever, and we can say that those two events are independent, then the result that comes out is this. Okay, so let's go ahead then and say then that two events A and B are independent if and only if the probability of A intersect B is equal to the probability of A times by the probability of B. And this is the formal mathematical definition of two events being independent. Now, when we actually go ahead and try to show whether two events are independent or not, we cannot assume that this is true, because if we assume that this is true, then we're assuming that they are indeed independent. So if we actually try to show that two events A and B are independent, we have to show that this is true by other means. Now, one of the primary means by which we do that is we use this law of probability that we learned in a previous section. We said that the probability of A union B is going to be equal to the probability of A plus the probability of B minus the probability of the intersection of A and B. So notice what we have here is this is what we want. We're looking for how can we find means by which we can actually determine the probability of A intersect B. So notice that if we go ahead and say then that the probability of A intersect B is just going to be the probability of A plus the probability of B minus the probability of A union B, which is just solving for this here, then we can actually determine the probability of A intersect B using other methods. So now what we can do then is that if we go ahead then using this equation here, because this is what we need to show if two events are independent or not, if we can show that the probability of A plus the probability of B minus the probability of A union B is the same thing as the probability of A times by the probability of B, then you've shown that those two events are indeed mathematically independent events. Okay, and there you go. that's why we can go ahead and determine whether or not two events are independent. And we can show that mathematically, of course, starting off with conditional probability, establishing what independence means, and coming out with this particular result. Okay, so let's see how everybody does. Let's give it a best shot, and we'll discuss this the next time that we meet. Okay, good luck. See you then. Bye.